In this lecture, I'm going to explain the default conventions built into Entity Framework and show you how to override them using data annotations. So let's start with table names. The default convention assumes the name of your tables is the plural form of your class names. So if you have a class called course, the table name should be courses. Now, sometimes you're working with a legacy database where the name of the table is singular, or it might be prefixed with something like TBL. In that case, in order to be able to map this course class to that table in the database, we need to use the table annotation. So this is just an attribute that we apply on the class, and we pass the name of the target table in the constructor. Now, the default convention assumes your database objects are in the DBO schema. If this table is in another schema, you can specify it here. Next, column names. So the convention assumes that the name of columns are the same as properties in your classes. Again here, let's assume we are working with a legacy database and we need to override the convention. So we can use the column attribute or annotation like this. Now we can optionally specify a type name. By default, strings are mapped to n_varchar. If you don't want that, you can override it here. Next, primary keys. So the convention assumes that if your class has a property with the name ID or the name of the class plus ID, that should be the primary key. It assumes it's an integer and an identity column. Now, this is a good convention and it works in most cases. But there are cases like the example here that it doesn't work. So imagine this property belongs to a class called book. Each book has an ISBN, which is a unique identifier for that book. And it's not an integer. It's a string. In this case, we need to explicitly tell Entity Framework to treat this property as the key. So we can apply the key attribute here. Also, since the value of ISBN is not generated by the database using identity columns, we need to use database generated attribute. This attribute takes an enumeration called database generated option, which has 3 members. None, which means the database is not generating values for this property. Identity, which means the corresponding column in the database is an identity column. And computed, which means the target column is a computed column in the database. For example, you might have a computed column called full name that combines first and last name columns. So you need to tell Entity Framework that the value of this property is computed in the database. Next, composite keys. So this is pretty similar. Note that here in the order item class, we have a composite primary key that includes order ID and order item ID properties. So we need to apply the key attribute on both of them. And additionally, we need to specify the column order. So be aware of that. Next, dealing with nulls. So Entity Framework assumes if a property is nullable, it should be marked as nullable in the database as well, which is a fair assumption. Now in C#, strings are nullable, but this does not always work for us. Think of the course class, for example. Every course must have a name. So in this case, we need to apply the required attribute to tell Entity Framework to mark this column as not nullable. Just to clarify, this is simply an annotation or metadata. It doesn't stop you from assigning null to this property in your C# code. But at runtime, when you try to save a course object, you're going to get a runtime exception from the database telling you that the name column cannot accept null. Here is another example. Each course has an author. So the author property is of type author and it's nullable. But in the real world, every course must have an author. So again, we need to use the required attribute here. Next, length of strings. So if you have a string property, Entity Framework assumes your database column is of type n_varchar of max. If you want to change the length of your column, you should use the max length attribute. So here we are limiting the length of name to 255 characters. Again, similar to nulls, this does not stop you from assigning a longer string to the name property in your code. It's just going to cause a runtime exception. Next, index. You can add an index on a property by simply using the index attribute. You can optionally set is unique equal to true to ensure that property or column is unique. So you may want to ensure that you don't have two courses with the exact same name or two users with the exact same username. That's when you use a unique index. If your index contains multiple columns, you need to apply it on multiple properties. So here we have an index on author ID and student count. And note that in this case, we need to specify the name of the index and an order for the columns in the index. And here's the last one, foreign keys. So if you remember, when we created our database based on our code first model, our foreign key columns had an underline, which some developers do not like. So if your course has an author, you will end up with a column in the courses table called author underline ID. How do we override this? Well, first you need to add a foreign key property in your model with the desired name. So here we add author ID. Now we need to link this property to the author property, which is a navigation property. It allows us to navigate from a course object to an author object. If you don't link these two columns, Entity Framework will create two columns, one called author underline ID, which is the foreign key, and another one, author ID. And these columns are not related whatsoever. So how do we link them? There are two ways. You can apply the foreign key attribute on author ID, and note that here in the constructor of foreign key attribute, we are specifying the name of the other property, in this case, the navigation property or author. Or you can do it the other way around. You can apply it on the navigation property and link it to the foreign key property. Okay, now let's flip over to Visual Studio and apply these annotations to our model.